Computers can perform innumerable tasks and calculations, but everything a computer does is based on two tasks: storing information and processing information. To begin our discussion of how a computer works, we will start by discussing how a computer stores information about numbers. Since computers use only two symbols, ones and zeros, to represent information, we need to represent numbers by using only these symbols. This representation of numbers with only two symbols is called binary number representation. As people, we use inherently meaningless symbols to communicate every day. By themselves, these symbols here don't mean anything, but we have developed a code called the English language that assigns meaning to the symbols. These symbols are the alphabet that we use to construct more elaborate words that can communicate more information. When using the English language as our code, we can tell someone to look for a four-legged animal that has pointy ears with a code word that consists of only 3 letters. However, the same message can be communicated with different symbols if we change the code. If we use the French language as our code, the four-legged animal would be represented with a code word of 4 letters. By changing the code, we change the meaning of the symbols. Whenever we display words, we must know what language or code is being used so that we can correctly interpret the symbols. While in French, CHAT means a cat, in English, CHAT means to have a conversation. Similarly, when we communicate information about numbers, we typically use these 10 symbols as the alphabet for our codes. When we use symbols to represent numbers, we call the code a base. Typically, we use a base called the decimal system, which is base 10. The base number tells us how many symbols are in the alphabet of the code. When we know the base, we represent number information by traversing across the symbols in the base until we run out of symbols, and then we add more symbols to represent increasingly large numbers. As we described in the digital abstraction lecture, computers use a two-symbol alphabet. Therefore, they use base 2 represented numbers, or binary represented numbers. We can combine the two symbols 1 and 0 to represent an infinite set of numbers. When we represent numbers, we have to indicate which base we are using so that the number will be interpreted correctly. For example, the code word with 2 ones is 11 in base 10, but 3 in base 2, just like how CHAT could mean either a cat or a conversation depending on the language. We indicate which base was used by appending subscripts to the numbers. When we write numbers, the value of the number is encoded both by the symbols and the positions of the symbols. While these two numbers here contain the same symbols, we interpret them as different values because the symbols are in different places. This notation is called positional notation. For decimal numbers, the position immediately to the left of the decimal point is assigned a weight of 10 to the 0, or 1. All positions to the left of this position are given increasingly greater weights. All positions to the right of the radix point are given decreasingly smaller weights. We find the value of the number by multiplying the symbol by the weight of its position. So here we have 1 1000s, 0 100s, 2 10s, 3 ones, and 4 tenths. When we use binary numbers, each position is assigned a weight that is a power of 2. This table here shows some common powers of 2 for reference. When we represent numbers in bases besides base 10, the decimal point is called a radix point. And similarly, like decimal, the position immediately to the left of the radix point is assigned a weight of 2 to the 0, or 1. all other positions are given weights accordingly. For example, the one in the farthest left position tells us to add 1/8 to the value of the number. The 0 in the next position tells us to add 0/4. The 1 in the next position tells us to add 1/2 to the total value of the number, and so forth. To summarize, we can represent numbers by choosing a code called a base. A base encodes the value of a number within the symbols and the positions of the symbols. We can determine the value of a number by multiplying the symbols by their weights and adding the products of those multiplications together. Be sure that you always indicate which base you are using so that other people can correctly interpret which number you meant to write.